Okay, today we're going to be talking about logarithmic equations. In order to solve logarithmic equations, we need to know the laws of logarithms. They are as follows. The product law says if you have log of A plus log of B, that equals log of A times B. The quotient law says the log of A minus the log of B, the log of A over B. And the power law says the log of A to the C power equals C log of A. The power law is what we were doing yesterday when we were solving exponential equations. That's where you make the exponent the coefficient, and there you go. So we need to rewrite the expression as a single logarithm, then evaluate their resulting expressions. This is an introduction. So if I have something like the log base 3 of 27 plus log base 3 of 9, they have the same base, so I can rewrite them as a single logarithm. And to do that, I know that addition needs to be rewritten as multiplication. So that gives me the log of 3, log base 3, of whatever 27 times 9 is. And 27 times 9 is okay, really? Here we go. 27 times 9. 27 times 9 is 243. So 243. And now you would put this in your calculator using the change of base rule. And that gives you the log of 243 divided by the log of 3. And the answer is 5. So now I'm on to the log base 4 of 192 minus log base 4 of 3. I know that subtraction means divide. So log base 4 of 192 divided by 3. And I can do this right in my calculator just like that. So I would do the change of base rule, and I would say the log of 192 divided by 3 divided by the log of 4. And the answer is 3. All right, for the log base 3 of 5 plus 5 log base 3 of 2, first of all, I need to move this 5. It needs to be an exponent. So now I would rewrite it as log base 3 of 5 plus log base 3 of whatever 2 to the 5th power is. And 2 to the 5th power is 32. And again, anytime you have addition, that gets rewritten as multiplication. So log base 3 of whatever 5 times 32 is. And you'd put that in your calculator. So you get the log of 5 times 32 divided by the log of 3. And that gives you an answer of 4.6196. All right, so now that we know how to do that, now we can talk about solving logarithmic equations. The steps are as follows. You do need to have this written down. Step 1, rewrite multiple logarithms as a single logarithm. Step 2, are there logs on both sides of the equal sign? If yes, you erase the logarithms and solve for the variables. If no, you rewrite logarithm in exponential form and solve for the variable. All right, so when we were solving exponential equations, we would turn it into a logarithm. When we solve logarithm equations, we turn it into an exponential. All right, so solve and round to 2 decimal places. So I'm going to move it over. All right, my first problem says the natural log of x equals 8. So do I have a logarithm on both sides? No, I don't. So I'm going to turn this into an exponential. Well, what I need to understand is that this has an understood base of e. understood base of e. So now I do my cycle and I turn it into an exponential. E to the 8th power equals x. E to the 8th equals x. Okay, so now x is all by itself, so now I can type it in my calculator. Second natural log to the 8th power, enter, and that gives me 2,980.96. 2,980.96. 2,980.96, because I said round to 2 decimal places. All right, now for this example over here, right here. Does this one have a logarithm on both sides? No, it does not have multiple logarithms either. So now I go ahead and I turn this into an exponential. 2 to the 3rd power equals 25 minus x. 2 to the 3rd power equals 25 minus x. Okay, 2 to the 3rd power is 8. Now all you need to do to get x by itself is subtract 25. 8 minus 25 is negative 17. And that equals negative x. And obviously you can't have a negative x, so you divide by negative 1. So that gives you x equals positive 17. All done, and I'm correct. All right, so I'm going to move on down, and I'm going to do this example. This time I say, are there multiple logarithms? And yes, there are. So I have to use my log properties on both sides. So I'm going to start on the left side. It says log base 2 of 3 plus log base 2 of x. Remember, when you have addition, that really wants you to multiply. So log base 2 of 3x, because 3 times x is 3x, equals, and on the other side I have log base 2 of 5 plus log base 2 of x minus 2. This one wants you to multiply also because it has addition. So log base 2 of 5 times x minus 2. Now, I said when I gave you the steps, look back up at your steps. After you've rewritten multiple logarithms as single logarithms, it says, are there logs on both sides? If yes, you erase the logarithms and solve the equation. Well, I have logs on both sides, so I cross them out. And I have 3x equals 5 times x minus 2. Okay, well, you need to distribute. 5 times x is 5x. 5 times negative 2 is negative 10 equals 3x. Now you need to move all the x's to one side, so you subtract 5x on both sides. And that gives you negative 2x equals negative 10. And you divide by negative 2. If you're struggling with solving equations, negative 10 divided by negative 2 is 5. If you are struggling with solving simple equations, like you can't do the solving equation step because you don't understand the logarithm step or whatever, you need to go to Khan Academy or YouTube and you need to search solving equations and watch a video on how to solve equations. All right, now I'm doing this example. This one says the natural log of 3 minus x equals 2. Now, I don't have any multiple logarithms and I don't have logarithms on both sides. So I'm on to the step where it says turn it into an exponential. Now, natural log has an understood base of e. So I have to write that in. And then I do my cycle. E to the 2nd power equals 3 minus x. Okay, I'm going to go ahead and get x by itself. I do that by subtracting 3 on both sides. So e squared minus 3 equals negative x. You can't have a negative x, so I'm going to flip my signs. So that gives me negative e squared plus 3 equals x. And now I'm ready to type it in my calculator. Negative e squared plus 3. And that gives me negative 4.3891. Negative 4.3891. All right. I would now like to do this one. All right, I have log base 9 of x plus 6 minus log base 9 of x equals log base 9 of 2. Okay, well, I have multiple logarithms, so I have to write those as a single logarithm. Subtraction means to divide. So I have log base 9 of x plus 6 divided by x, because subtraction means to divide. Now my next step says, are there logarithms on both sides? Well, the answer to that question is yes. So they just go away. And I'm left with x plus 6 divided by x equals 2. Okay, now we're on to simple solving equations. If you can't solve equations, you need to watch a video on how to solve equations. Okay, you have a variable on the denominator, and you need to multiply that on both sides to get it out. So the x's cancel, and you get x plus 6 equals 2x. You then need to subtract x on both sides. 2x minus 1x is 1x. So x equals 6. And my last example is right here. Log base 5 of 6 plus log base 5 of 2x squared equals log base 5 of 48. My first step says rewrite multiple logarithms as a single logarithm. I do need to do that on the left side. Addition means multiply. So I get log base 5 of 6 times 2, which is 12, of 12x squared equals log base 5 of 48. My second step says, are there logarithms on both sides? Yes, there are. Because there are, I cancel them out, and I get 12x squared equals 48. Now I need to get x squared by itself, so I divide by 12 on both sides. So x squared equals 4. And then you take the square root on both sides to get rid of the square. This is old news. And x equals plus or minus 2. Because whenever you take an even root, you always put plus or minus. Okay, I'm going to go further into this when you come into class. I'm going to do a few that are a little harder. But make sure you have these down and make sure you've written the steps. Because if you ask me for help in class, the first thing I'm going to say is, do you have your notes with the steps written so I can refer to those? All right, thank you.